Hello, my name is Charles Simoneau. I'm an FEA consulting engineer at Simitech, based at Montreal's office. In the next few weeks, I'll be posting some video to present the complete simulation workflow of ANSYS for additive manufacturing. And today's presentation will focus on a general introduction to additive manufacturing, the position of ANSYS in relation to additive manufacturing, and the main challenges. So we'll start from the beginning. Based on a standard, additive manufacturing is a process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive or formative manufacturing methodologies. Additive manufacturing is enabling three unique capability that other formative or subtractive manufacturing cannot really do. So first of all, we're talking about a hierarchical complexity with the possibility to print a lattice structure and at the inner core of a part. So this is really interesting. Material and shape complexity. So we can print any kind of material. So we're talking about polymer, ceramic, metals, and in the families of metal, we can print almost any metallic materials. Shape complexity, we're talking about having the possibility to print personalized implant that would meet the specific needs of a patient. So this is a custom fit. And functional complexity, we are able to print already assembled component and even to consolidate part, which is something that can reduce the cost at the end of a product development. So today's presentation will focus on laser powder bed. So I will not talk about FDM or SLA or other plastic additive manufacturing process. So laser powder bed fusion, why? Because laser powder bed fusion is one of the commonly used process to produce metal parts. Laser powder bed fusion is an additive process in which thermal energy selectively fuse a region of a powder bed. So to this end, I have this little video for you. So we start by applying a thin layer of metallic powder, and then a laser comes and selectively fuse the metallic powder at a specific area. Then we applied another layer of powder, and the process goes on and on again, and in a way that we can print a part directly from a 3D model data. So like I mentioned, this is the most commonly used process to produce metal parts, and this is where we are going today. So pretty simulating this the additive process for metal parts. As you may know, if you are a bit aware of additive manufacturing, so especially with the laser powder bed fusion, there's a lot of challenges with that comes with this process. So we cannot simply send the part to a 3D printer machine and get our part done. So a lot of work has to be done. So for example, in terms of part orientation, generating the support structure, so those key parameters can have a direct impact on residual stress and part distortion. So these are the main challenges that the design engineer and the machine operator will face during the preparation of a build, and not correctly orienting the part or not putting enough support structure can lead to some build failure and some cost. So this is very big challenges. And for research engineer and material scientists, the challenge that they are facing are a bit different. So they like to develop some new metallic powder, develop some new process parameters They like to have an idea of the microstructure, the mechanical properties, porosity, melt pool, and so on. So these are other kind of challenges that those people will face when using this technology. So a lot of known challenges, and so this is the reason why simulating the additive process becomes attractive, because we can at some point alleviate those challenges. So this is why ANSYS is coming with a complete design to print solution, especially for the laser powder bed fusion process. So it starts with the part that is called design for additive manufacturing. So it basically focuses on topology optimization, and then goes into the additive manufacturing process simulation to, for example, select the proper orientation, generate some physics-based supports, simulate the process simulation itself, and then predict some outputs in terms of microstructure, mechanical properties, and all of those different things. So this is where ANSYS is in terms of additive manufacturing, so a complete design to print solution. First of all, I just want to give you an overview of some key parameters that needs to be taken into account if we want to simulate the additive process. And I'll just go with an example about the multi-scale aspect. So we are facing a multi-scale analysis. So for example, at the micro scale, the part size that we print can be up to cubic millimeter or cubic centimeter. So it's kind of a good part in terms of size that we can print. But if we look at the micro scale, those parts are printed layer upon layer, and usually the thickness of a layer is around like 30 to 50 microns. So we really have this clash in terms of physical dimension, because in terms of simulation, if we want to simulate that correctly, our mesh would have to be fine as maybe half a layer thickness, and you can just imagine what would be the size of the mesh if we want to print a size that is like 10 or 20 centimeter high. So this is this is the good example of the multi-scale challenge we are facing, and this is the same thing for in terms of time. Printing a part can take up to hours or some days or even 1 week, but knowing that when the laser is melting the powder, the solidification process can take 1,000 or 10,000 of Kelvin per second. Just again imagine what would be the time step required to capture the solidification process, and knowing that a build can take up to several hours or day, it will lead to an infinitely number of time steps. So there's a lot of challenge. This is only for the multi-scale, and you have other kind of challenge that we are that we must taking into account if we want to correctly simulate the additive process. Knowing that, ANSYS is offering 3 products to simulate metal additive manufacturing. This is always for the laser powder bed fusion. So 3 product, one called additive print, the other one workbench additive, and the third one additive science. So that concludes this video, and in the next series of video I will presenting these products in details along with some demonstration. Thank you for listening. I hope you like it, so feel free to contact me if you have any question related to additive manufacturing. You have my email right here, and stay tuned for some more additive manufacturing videos.